So hello everybody, welcome to the tutorial session of system commands. Am I audible? So
Yes, you are audible.
yeah, so today so Sir has joined the session, and I think this will be a good experience for you guys. This will be a kind of live teaching session with Sir today, because he will be doing the revision for weeks 1 to 4. So I hope you guys are preparing for the quiz, and you guys are preparing well. So if any doubts or difficulties, that can also be discussed today. So after the revision session, in the today's session itself, we can discuss the doubts. Yeah. So
Hi, Ankur. I just had to finish one call. Yeah, back.
yeah. Yes, sir. So students have joined,
Okay, good.
and they're
So
still
yeah.
joining.
Let us give a minute or two, and then we can start discussing.
Yes, sir. Sir, is there some sir? Is the light low in your room or something? The screen is flickering. It seems to me.
Yeah. I too noticed it was not normally flickering, so I'm a bit surprised. Yeah. Of course, there's a fan. I mean, it's all the same actually. Let me try something. I have some other light to help.
So seems like, sir, as you stood up, the flickering stopped. So
Because I
the
was closing the camera. So
okay. So seems like the back, if that window is out of the frame, then I think it would help.
so
That
that's why
may
I'm trying
cause
to.
that.
Yeah, so I'm just trying to put it off in some direction. I
Yes, sir.
think now
It's
it's
better now. It's better.
much better. Okay,
Okay. Yeah. Thank you, sir.
okay, okay.
Yes, sir. We can start, sir.
Hmm. So yeah, you wanted to go with the slides. We saw like just to
Yes,
run
sir.
through, and then
Yeah, we can go through that.
yeah, after that I will share the screen and then
Yeah.
show some things. Yeah,
So should I share the slides?
yeah. Now you can do. Yeah.
Okay, just a second. Yes, sir.
Yeah, we can see that. Okay, so yeah, Ankur, you want to speak or shall I just
Yes, sir. You
say?
can go ahead.
Yeah, so I just keep saying things and then tell you to move on to the next slide. So we
Sure, sir.
just
Sure.
quickly do some thing. So the first thing is about the terminal. Long back, it used to be the physical terminals, which are like a television and connected with a cable to the mainframe computer. It's called console. And so today we have a graphicalizer environment. So what would happen is that you need to have an app that will actually be doing the emulator of the terminal. So what is that app? You have many apps. Normally on Ubuntu, you have terminal app. And if you are using a WSL on Windows, it will be the CMD command line app. And there are also other apps like console, xterm, and guac and all that. So you can choose your favorite. Guac is quite good with the F12 key. It can bring it up and close it with just a stroke of F12. So that's quite convenient. Xterm is very thin. It doesn't take much memory. So, and terminal is quite good because it has ability to show colors and all that thing, and it can also customize fonts and all that. So you can choose whatever your favorite. And very often when you open a terminal environment, you need to know where are you, in the sense what is the current directory in which you are currently working. So pwd will tell you where you are, present working directory. And you need to familiarize yourself with the contents of the directory. So you would run ls command to see what all the folders that are there, and you can go into the folders, come out using cd command. And you may be interested to know what is a shell that you are right now running. So ps command will tell what are the processes that are running, and it will show you that there's a bash shell that is running in the terminal, which is taking the commands from you, sending it to the operating system, and then showing you the output. So ps will tell you what shell is right now running. Okay. um, and then uname is basically a command to tell what type of an operating system are you using. So if you type uname -a with the option -a, it will show you the entire details of the kernel and so on. But uname alone will show you what type of an OS it is, and it will show you Linux with capital L. And very often, many shell scripts which you will be learning as you go along will use the output of the command uname to determine what OS it is. So all the Linux will only show you Linux, but then what else can be shown? So uname is actually supported by many other operating systems like AIX, which is an operating system from IBM. And in the past, it was supported by Solaris, which was operating system from Sun Microsystems. Okay, and there are also HP UX from Hewlett Packard. So many operating systems used to be there, which are Unix-like. I think today only two such versions are, I think, what you can see. AIX is alive, and the Mac OS is alive. These two are Unix-based. And then, of course, Linux is there plenty. So you will only see AIX, Mac OS, or Linux usually. Okay, just to go back. We have yeah, so clear and exit, these are all basically to make your terminal comfortable. So as you keep typing commands, you can see some displays getting cluttered. So you want to clear the screen, press Ctrl L. And then, of course, when you are done with your work, you can press Ctrl D to come out of the shell. So I mean, how do you enter the shell and come out is something that you should be familiar. Yeah. Okay, so let's move further. Okay, let's move on. Yeah. So ls-a should show you the long listing of your current directory to show you the all the files and directories in the current directory. And from the display, you can actually make out whether the file has permissions for you to enter or execute, etc. So those are the kind of things that you will have to pay attention to in the display that is given on the screen by ls. ls-l is a long listing. ls-a is all. That all as in even the directories that start with a dot. So some directories are starting with a dot character so that they are not displayed by default, because you don't need to work with them on a daily basis. Okay, they are meant to be used by the system. Okay, yeah. Yeah. Okay, next. Okay, now to make yourself familiar with what you are seeing on the screen, normally when you open a terminal, usually the prompt string, what is there as user at machine colon tilde dollar, that entire thing is called as a command prompt. Okay, the prompt string. So the prompt string can be customized. Okay, in my lectures, I have also shown how to customize these strings. But the default, what is done in Ubuntu is that the username at the machine name colon the directory, and then the dollar is the uh, prompt string. Okay, and in my case, it will be like gfunny at icme colon, okay, tilde dollar. And in your case, it will be your username and machine name. So pay attention to what is being shown. Okay. And then the command will be written in three parts. There's a command, after that there is some option, and after that there's an argument. Okay, so not all commands require the options or arguments. So you have to see that these are the three parts. Okay, the command, and then the option, and then the argument. Options usually have either a hyphen or two hyphens. A single hyphen option is called a short option. Double hyphen option is called a long option. So usually it will be a full name, like minus verbose versus minus v. So minus v is a short form, minus verbose is a long form of the same option. So something like that. So pay attention to what are called the options. Options are different from arguments. Options change the behavior, how the command will work. Arguments are the inputs to the command. Okay, so these are the two different kind of things. So whenever you run ls minus a, what is the argument? You're not giving any argument. So the default is you are saying list the files in the current directory. So there is an implicit argument which is the current directory. Okay, that is what is understood. Okay, next. Okay, now here is an example of an argument. So man is a command, and what comes after that is an argument. So ls in this case happens to be an argument. Okay, so you are asking man pages of the ls command. So that's the meaning of this command, man space ls. So the first thing is command, second part is argument. In between, if you have some things with hyphens, they are basically the options. Yeah, next. Okay, now man pages actually come in many sections, so you can give these as options also. So usually we are interested in the first type of man pages, section 1. So many of these sections are for legacy reasons in Linux. You don't have to worry about them. If at all a man page is available in multiple sections, and man command wants you to pick one of the sections, it will prompt you. So therefore you don't have to worry. But here is just an information to you that man pages come in many sections, and the first section is what most of us will generally tend to use. Okay, next. Okay, yeah, Ankur, next page, next slide, please.
Just a second.
Yeah, you are, I think, trying to size it. Huh?
No, actually, I moved to read mode, then the arrow keys stopped working.
I think, yeah, let us, it's okay. I have ensured that the font size is quite big, so I think it's okay. Huh?
It's okay now this way.
Yeah, because font
Okay.
size is quite big. People can read it.
Yes.
Okay, yeah, here is is a usage of the man command with the option. So one is the section, ls is argument. So options are taken in the first field, the second field is argument. And this option is just the section number. There's no need of a minus, hyphen or anything like that. So this is a broadly the pattern of every command. There's a command, there's an option, and then there's a series of arguments, at least one argument usually. Okay, and options are not necessary sometimes, arguments are not necessary. So command can also come alone. Okay, so be prepared to detect which is what. So the first is command, second is options. You can also come see the options as minus, usually the hyphen. So you can detect the options, and argument comes usually towards the end. You can mix and match also. You can actually have options, arguments, option, argument, option, argument. You can do that mixing also. It's possible. Okay, next. Yeah, so here is a official documentation. So I want you to realize that Linux has a standard. Okay, that means whether you're working in Japan or India or America, if it is a Linux machine, there's a certain file system hierarchy that you can expect to see, and that is according to an international standard, and it is documented very well on the internet. So here is a URL for you to go and look it up. So this standard will tell you which folders are meant for what purpose. So all the Linux distributions will follow that format, which is very good because you then understand where to expect what kind of a files. Now the discipline followed by Linux community is evident that hundreds of Linux variants are available, but all of them will conform to this particular file system hierarchy. Okay, that is amazing. Secondly, all of them are volunteers in many different kind of walks of life, but yet they all conform to standards. On the other hand, let us say, Microsoft, even though it is a single company, it was not able to stick to a expected directory system even across its own operating system variants. Like for example, Windows 95, Windows 98, Windows 2000, and then Windows NT, Windows XP, Windows 7, Windows 8, Windows 10, Windows 11. Any of these, if you see the way the files are stored, they keep on changing that, and it's not documented very well outside, and there is no standard to that. In fact, the standard is not followed by their own company. So it then, I think you understand that it's a very big deal that Linux is able to stick to a standard across the disciplines, across the countries over a long period of time. Okay, so try to go through the standard at your leisure. There's no urgency, so that you can be at home wherever you are in a Linux system. Yeah. Yeah, we may want to go a bit fast. Yes, let us go. Yeah, move on. Okay, so this is a broad hierarchy of the file system. So make yourself familiar with the names. Home is where your own files will be sitting. Temp is a temporary files are sitting in that. And then var is rapidly changing files which are for the runtime environment. Bin is where the executables are sitting for common purpose. Sbin are executables which are meant for system administration. So each of these folders have specific purpose and specific type of stuff are to be found. So make yourself familiar so that the hierarchy of the file system is sort of etched in your mind, so that wherever you go, whichever system you use, if it is Linux, then you sort of know your way around. Okay, yeah. Man minus one. Minus is because it pras is asking a question. Well, it doesn't expect a hyphen for the option. That's all. Okay, because every command has documented how the option should be given. Okay, so you should go by that documentation. Hmm. The hyphen is used by many commands, but it's not compulsory. You have to only know first. You have to supposed to do the man page to see how are the options and then use those options, and that is the expected behavior, and it is documented. It's documented. Yeah. Next. Yeah. So yeah. So how do we traverse? So you know that the root of the file system, the starting point is the slash, and you can also use the slash as a delimiter for the subdirectories. So you can say slash bin slash something slash user slash bin slash something. So slash is basically a delimiter as well as the root of the file system, and every directory will have two entities called dot and double dot. Dot is the nickname for current directory, double dot is a nickname for going to the parent directory. So you can say cd dot, nothing will happen because you are in the same directory. Cd space double dot, you'll go to the parent directory. So you should be able to go up and down the hierarchy of your system, and then keep putting the commands like pwd and ls, so that you see where you are and what are the directories and files that are present, so that you can make yourself familiar with the file system. Okay, yeah. Next. Yeah, next please. Yeah. Okay, so this is a typical place where we store. So where is the directory that I've logged into when I open the terminal? So I'm in my home directory. So slash home slash gfund is my home directory. And in that directory, I have already some folders that are created like desktop, documents, downloads, pictures, etc. These are given by the system, and I can create some directories for myself, like my code, where I can keep some stuff for myself. So make yourself familiar with this hierarchy, so that when you download something, where are you supposed to find it? When you create a document, where are you supposed to find it? Usually, if you create a document using LibreOffice or something, they will all be stored in documents folder. And then when you download something from the internet and save it, usually it will be in downloads folder. If you take a screenshot, it will be stored in pictures folder. if you record a video, it will be in videos folder. So there are specific default locations that stuff goes and sits. Well, you can always move them around, but you should make yourself familiar with where are those sitting. So use the cd command and ls command to traverse this hierarchy in your own system and make yourself familiar. Yeah. Okay, next. So here are some standard directories I just mentioned just a while back. So slash bin is for the usual commands that are to be run by everybody. And the boot folder is something where you don't need to go and do anything because it's meant for the booting of the system. There are situations where we need to go and do some changes, but not at this entry level. One has to be a system administrator to do that. Slash dev is also a folder where you don't go and touch anything. It's a place where all the devices are actually located as files. And if you have a hard disk, if you have a USB disconnected, if you have a monitor connected, keyboard connected, all these are devices sitting in the slash dev folder. Okay. etc is where the configuration of the systems and subsystems are located. So if you want to know where is the network configuration or USB configuration, etc., what actions are taken by the system when I plug in a external disk, etc., all of those configurations are all sitting in etc directory. Slash lib is for the libraries and the kernel modules, which means that slash lib is a location where the functionalities are being integrated with your operating system. So fairly sensitive directory, one should not disturb that. Now when you actually plug in some USB disk or a CD in your CD drive or something, they will be made available to you on the folder slash media slash username. Okay, so media is meant for removable devices. Now, if you are going to also mount it, a device, you can also do it yourself, and you can normally do it in slash mnt because it's expected to have that. You are welcome to mount any file system anywhere you want. Okay, you can do it anywhere you want, but if there is no special purpose from you, better to keep it in slash mnt because one expects the mounted points to be there. Okay, mount point means the placeholder for you to access those respective hard disks, okay, storage devices. Okay, slash opt is a folder where you have optional software that are added, particularly if you are going to store them in a separate hard disk, etc. So these are things where you can remove them and it doesn't hurt your operating system. Okay, so slash opt is a place where you have installed some special software for your special needs, and if you remove them, your operating system will not get affected. Okay, but everywhere else it may get affected. Okay, yeah. And of course there are some other folders which are the runtime usage, so slash run and slash tmp and slash var, these are used by the runtime systems. And slash user is another hierarchy of the file system. This is what do you call, I would say chronologically it came a little later. Okay, so there's a chronological reason for why you have in ubuntu, for example, very often slash user bin is the same as slash bin. Okay, so there's no need to have two separate hierarchies. Okay, and sbin generally, like you have seen for bin, sbin is a directory where the system administrator tools are available. It is expected that a normal user using the computer for normal usage will not require anything from slash sbin usually. Okay, and if you need to do something in sbin, you are expected to have super user permission. That means the system will prompt you to give the password, and you should be able to enter the password, which should correspond to a user who is listed as administrator, and such administrators are allowed to run those commands. Okay, next. Okay, the user hierarchy is the second hierarchy, and many of them are mapped with the directories without the user. So slash bin and slash user bin are the same in Ubuntu, for example. So slash lib and slash user lib. Okay, but in many operating systems, they are kept as separate hierarchies, so that the basic ones are without the user, and the specific ones for that particular distribution are kept in slash user. So it's a decision from the distributor. Okay, and other than slash user, the remaining part is more or less same as what I have discussed. So slash user slash bin are for administrators, for example. Okay, next next slide, var. So var is actually used by the runtime system. So let us say you have a email server, so emails are going to come and sit in var directory in var spool, for example. Okay, now you are going to have a printer. Okay, var directory is where it will have the printer queue also located. Okay, it will be where spool again, where local etc are for local data. Where lock is a very important folder. Whenever you open any file for writing, so the file system will actually lock the file, so that while you are writing, others do not want to should not be allowed to write to the same file, because sometimes if you write without synchronizing the changes, the file can get damaged. So that lock and unlocks mechanism is already there, and the software will all do those things by keeping the lock in the /var lock folder. Okay, so you can actually watch that folder and see which files are being written to by various subsystems that are running in the background. Okay, for your curiosity, where log is a place where all the data logging is done about the usage of the system. So whether you have run some command successfully, or was there any failure, and let us say there are some packets of internet packets that are blocked by your firewall. Okay, all kinds of activity in the system can be observed using Verilog. If you are running some Apache web server or MySQL database server, all of them will also write their logbook to Verilog folder. So Verilog is a directory where administrators always keep looking at to understand how the system is functioning, and particularly the error messages, so that you understand what's going wrong with the machine. Okay, so Verilog is very important for administrators. Okay, next. Yeah. So here is a broad summary of what folders are generally supposed to be static and what are variable, and what can be shared across machines and what should not be shared across machines. What do we mean by shared across machines? Like, let us say you have a cluster, you have got like 10 or 15 computers connected as a cluster. All of them are supposed to boot with the same operating system, and they are supposed to talk to each other for computing. So you don't need to waste space by installing all the things in every machine. Some of them can be shared. So which folders are expected to be shared, which are not to be shared, are given. So this is something that system administrators should be aware of. Hmm. Yeah. Yeah. Next.
The last slides.
Yeah. So yeah, we can then move on to the next guy.
Yes.
So by the way, as I am just reeling out, we are only trying to recap what has already been elaborately discussed in the videos. So feel free to ask if there's any question, because this session is mainly for interaction.
So is the slide visible?
Yeah, visible. Yeah.
Okay.
Okay.
So
So
what
here
is
are
the
some.
file system of Linux called? For example, Windows, we have NTFS. What is the
Yes.
file system of Linux?
Linux actually has multiple file systems. So usually you would have file systems like RiserFS or ext. So I'm writing in the chat window for you. So ext4 or RiserFS are the file systems typically, and you also have some different ones. So ZFS also is available. Okay, so most probably your Linux will be ext4. Okay, ext is a file system which is also called as a journaling file system. So which means that if there is a power cut suddenly, the files will not get spoiled. The system understands that certain files were not written to in the previous running of the system, and it is able to recover the files, etc. So it has that journaling capability, and it is superior to the Windows file systems by a very important feature, namely, it will write the file system hierarchy at multiple locations, which are called as magic sectors. Okay, sectors. That is, if you have a hard disk in which there's a physical damage in the beginning part of the hard disk, or in the middle, or in the end, then you should not lose all the contents of your hard disk, right? So the Linux operating system basically uses the file systems like ext4, which write the file system entries, that is which file is at which location, etc. That information is written at multiple locations in the disk, so that in case of any hardware failure of the disk, the disk is still available and you can read the contents, and it will also report to you that there is a sector that has failed, so you should replace your hard disk in the near future, etc. It will alert you. Okay, so magic sector is a very important concept which originally was not there in Windows. Okay, that's why in Windows long back, if some hardware failure happened, then your disk is gone for good. Okay, so that's one thing where very early Linux is like superior to Windows. So the short answer for you is ext4.
Okay, sir. And sir, any short command that we can just type to see this particular thing, or
Yes,
this
yes,
command does
yes.
not make sense?
No. It has. This is not a command. I am giving you our names only.
Yeah, yeah,
So there,
yes.
so there is a command to know what type of a file system. So I would actually just type it. So if you do mount, okay, just type the command mount. Okay. Now then you will see what all the folders that are mounted with what options. So you will see that something will be mounted as vfat, something will be mounted as various names will be there. Okay, and in those names when you look, you will see the type of the file system also. So for example, I will share the screen shortly later. At that time, if you remind me, I will run the command and show you. So from the command mount, you can identify what is the file system of that particular disk that you have mounted. Okay, now these are some utilities that are very useful in the beginning. So date
Sir,
command to know the date and time.
sorry,
Cal
sir.
command for go ahead, yeah, ask
There
me.
is a hand. Somebody
uh,
wants to ask something.
i I have to
Yes,
open the
sir. Yeah,
Yeah,
I
go
was
ahead.
raising my hand, but
Yeah,
should
go
I
ahead.
wait for the end? I have a couple of questions to ask.
you can ask right away. In fact, I prefer question answer than talking, huh?
All right, sir. Thanks. So I have a couple of questions.
Yeah.
Firstly, the order for the options of a command, for example, ls aih or ls iah. I
Yeah,
believe you said that the order doesn't matter.
order generally doesn't matter. Generally, as in, I'll give you an example. Okay, some options expect the argument to come immediately after that. Okay,
Okay.
so for example, there's a command called tar. Okay, so tar is a command to club various files and put them together, okay, as a tape archive. Okay, now the tape archive should have a name. So tar has many options. One of the options, which is -f, expects the file name to come immediately after that. So which means that when you type a command, I will give the command in the chat window. So normally, if you want to create -cvf, then tar file name dot tar, and then directories to be tarred. Okay, so that is roughly the kind of format. Tar -cvf, file name of the tar file, and then the directory is to be tarred. Now -f is an option for which the tar file name dot tar is what is expected as an argument. So the tar file is asking, tar command is asking what is the file name in which I should store the archive, and so you are giving the name. Okay, so the f should immediately be followed. So other variants for this could be like this: tar -c -v. Okay, I would say -f, tar file name dot tar -v direct. Okay, so this is also quite valid in the sense, all that you have a compulsory thing is that there's a file name coming after f. That's all. After that, the remaining options can come before or after, doesn't matter. So when I said the sequence of options doesn't matter, it's only subject to no option seeking an argument immediately after it. Okay, that is a clause.
Okay. Okay.
Okay,
So
yeah.
actually, also then like we can separate all the options by having like putting different hyphens in front of them. So we need
Yes,
not
yes,
have
yes.
them
You can.
together.
Yeah, you need not have them together. You can separate them also, no problem. Okay, all of them are equivalent versions. Yeah.
So this requirement, I think, like, do we have to provide the names before or immediately after? Like these requirements are already stated in man pages, right?
Usually it will be available. Which option requires which argument is what is to be found out from man page only. Okay, because man page is the authentic information for that particular command. So for tar, f is a very special option because after f, file name is expected. But such options are very less, very few. Okay, so don't worry. You will use them as you get familiar with the system.
Okay. And sir, my last question is, as regards the quiz itself,
Okay.
how much are we supposed to memorize things by heart? Because, for example, the shareable and unshareable directories,
Aha.
etc. Because
So
some other subjects have mock tests, but system commands doesn't. So I'm just slightly worried about how
okay.
much I should learn by heart.
Don't worry. So we have always taken care of that. The first thing I want to tell you is any question that has anything to be remembered, we will give the relevant documentation from the man page as a part of the question. Okay.
Oh, okay.
Okay, we will give that visually. Okay, so if there is anything to be remembered, like for example which option is for what type, etc., we will try to give you certain information in the question itself, so that if you read that text you will understand which option you should pick. Okay, now it is not applicable when you have never used that command. See, for
Yes.
example, you have never used the command. Now how are you going to understand which option is for what? So it is only given as a help for somebody who has already used it once, so then they understand which one to pick, but it's not meant for somebody who has never even looked at. So it's like, I will say, I mean, if you have studied, all that you need is a hint. Okay, the hint is available. Okay,
Okay.
yeah, if you have never studied, you don't need to, you don't know even where to look for, and obviously that is not the case that we are interested in. So we expect all of you to run the commands at least once or twice and then familiarize yourself. So therefore our hints are sufficient. Second thing I want to mention is those questions where little bit of recollection is being tested with help, of course, I have found that actually the students performance is much better than other questions which are analysis type or application type. So do not assume that students will not do well on questions where recollection is being tested. Our data shows that students perform actually better in such questions. Okay,
Okay.
of course, though they do better, we still don't do too many of them because we don't want you to recollect all the time. So we have a certain proportion of questions for recollection type, application type, and creation type, etc. So we have our own pattern of testing. So don't be worried about that. Okay,
Okay,
yeah,
sir. Okay, sir. Thank you,
yeah,
sir.
yeah.
So just to add to this, the memorization questions sir is talking about are the very basic ones that you should remember if you have practiced anything.
Yes, sir.
So
Got it, sir.
for example, ls, I mean,
Yes.
see, I mean, if you say I don't even want to remember what is ls, then it's very difficult because you can't even start, right?
Yes, sir. That's
So
correct.
yeah, pwd, ls, cd, these are like very very common. It's like, I mean, you can't go onto the road with a bike and then tell the traffic police saying that I have the manual of the bike with me, so I will somehow drive it. I don't think he will buy that argument, right? You should know how
Yes,
to
sir.
apply a brake and turn. So very basic, very basic you should know. Okay, and don't worry, it will come. By now you would have already been familiarized. Hmm.
Yes, sir. Sure, sir. Got it.
Yeah, yeah. Bhavya is asking.
Yes, will we be
Huh.
having MCQs and numerical type, or will there be something subjective as well, like questions like fill in the blank with the correct option for the command to be used?
Usually we, if at all there's a fill in the blank, it's a number usually, because we are going to have auto grading for the questions. So auto grading is possible only if you have some strings which are exactly comparable, or numbers. So wherever there's a fill in the blank, it is usually a numerical value usually, and the remaining ones will be like MCQ, pick the correct option, etc. And not all MCQs are like single answer. Some MCQs will have more than one answer, and we don't penalize you for picking only one of the multiple correct answers. The marks will be divided equally. So let us say, for example, there's a question for which A and C are correct answers and you have given only A. That doesn't mean you will get it wrong. You will get half of the marks. Okay, so it is quite reasonable.
But
Right, sir.
just to
And
add, if you mark any of the wrong answers, then you won't get partial marking for the correct ones also.
yes, sir, got it. And so for say, like the grep command has a lot of options, right?
Ha,
So
ha.
say, so I'm assuming that as per what you said, all of the options would be provided in the question, right? Like what the
Yeah,
option
most of them.
does.
Yeah, most of them which you need to solve that particular question will be used. Now what I will not tell is about the description of all those options in detail, because and then that means that
Yes, sir,
we
sure.
are
That,
having,
yes, sir.
right? So what we normally consciously try to do is that what is the hint which will avoid the memory part of it, so that somebody who has already tried it once is immediately able to do it. This is how we think normally, and I hope you are also in line with this thinking.
Yes, sir, sure.
Yeah.
Thank you, sir.
Okay. Okay, anyone else, anything else you want to ask? So the commands that you see on the screen, like date, cal, free, groups, file, these are all like initial commands for you to make yourself familiar with the system. So the system can tell you what is the date and time that it is currently noting. What you can get the calendar of the month. You can get the calendar of any month actually, and then you can get how much of memory is available in the computer and such information. Which user groups do you belong to, so that you can go and perhaps access files which you don't create but are available to you. Okay, and you have a file and you want to know what type of a file is it. Is it a script? Is it a image? Is it a executable, etc.? So you can actually inquire what type of file it is, etc. Now here again I want to tell you that in Windows the name of the file is used to judge what type of a file it is. For example, you have something called jpeg, something.jpeg. The system will think as if it is a jpeg image and try to open it and try to show it as an image. Okay, now this is how viruses spread. The viruses will come and disguise themselves as something else, and then penetrate into the system. Linux actually by default doesn't assume anything about the type of a file. You can give any extension you want, but the type of a file is embedded in the first few bits of that particular file. So that is what is inquired by the file command to tell what type of a file it is. So you can never cheat Linux about a type of a file because it is available to it from the file command. Yeah. Okay. Yeah. Next. Yeah, Ankur, we can move to the next slide. Yeah.
This ls minus l output also.
Where is that?
So is it not moving?
No, it's not moving. The screen is showing me the date cal free groups file slide
Okay,
number
okay.
2. It
Let
showing
me
me the
reshare
slide.
the.
I see it got frozen maybe.
Okay, is it good now?
Yes,
Yeah,
sir.
now it's okay.
Okay. Yes, sir. So
Yeah,
is
so
it?
the ls minus, yeah, so when you type ls minus l, you are seeing what is called the long listing. The long listing has a particular sequence of information which is all very valuable. So I want you to know which piece of information is what. So the very first character tells you whether it is a directory or a file. So if it is a directory, it will be D. If it is a file, it will be a dash. And then there are 9 characters which will tell you the kind of permissions. So the first 3 are permissions for the owner. Next 3 are permissions for the group. Last 3 are permissions for the others. Now, who is the owner, who is the group is listed in the subsequent fields after the number of hard links. Now, what is a hard link, etc.? I will be demonstrating once more to you shortly by sharing my screen. Then the owner and the group in this case happens to be me, my name, but it can be different also. Okay, in a system. Now the size is in bytes, so you have got the number of bytes occupied by that files shown, and then there is a stamp of last modified information about that file. Following that, the file name is shown. So you can see that the listing is such that it shows you fairly extensive piece of information about what is a file, when was it modified, how big is it, which group it belongs to, who is the owner of the file, how many links are there for that file, what are the permissions for others, for the group, for the owner, and what type of a file it is. So much of information in just one line for every file. Okay, so try to read this line by looking at the fields for the respective information so that your eyes will pick the information readily whenever you type ls minus l command. Okay, yeah. Next. Okay, so the very first character, as I mentioned to you, will tell you the type of file, whether it is a directory or a regular file. So hyphen will be for a regular file and a D for a directory. But there are some other characters also which will show you if this is a special file. So L will be for a symbolic link, C for a character file, B for a block file, S for a socket file, etc. So when I am showing you the concept of hard link, soft link, you will see that the L will show up there for the symbolic links, which tells you that it's a pointer to that particular file. It's not the file itself, but a pointer to another file. Okay, so pay attention to what is the first character in the long listing. Okay, now the idea about the hard link, soft link is something that I'm going to show you now. So every file is noted down in the file system using entries called as inode. Okay, so these are, like, you can say, as data entries. So inode number 1, inode number 2, like that. All the files are stored with the sequential numbers, and whenever there is any entry with the multiple names but the same inode number, it means that they're all basically pointing to the same file. Okay, inode like is a identity of a file. Okay, so if there are multiple entries with the same inode, they are all called as hard links. Okay, now when does a file get deleted? When all the entries against an inode are removed, then the file is removed. Okay, until that point the file is still existing. Okay, so this is a very interesting concept, and this is not given in this kind of a articulation in the Windows systems. This inode concept is coming very early in the file system in Linux, because it comes from the Unix operating system itself, and it's a very powerful feature because you can know a lot about file system once you start looking at these numbers. As a regular user, you may not need them, but it's a good idea to just go and look at those numbers and see, because it conveys you certain information that normally you can't see otherwise. Okay, so on Windows, for example, it's very difficult to see this kind of an information. Okay, and you may be wondering, those people who have these repair shops who take a hard disk and then say that they can extract files for you and then give it to you, how do they go about? Exactly, these are the information that they are going to look up. They are going to read everything in the disk and then reconstruct the files by looking at the inode numbers from the file system entries. And even if the hard disk is broken, they can read how much ever they are possible and assemble the files, keep them in a separate location, and then give it back to you as a service. Okay, so I mean, it has ability to sort of resurrect a broken hard disk, and therefore it is very robust implementation of the file system. Yeah, yeah. Now sockets, yeah. So Ankur mentioned sockets. What is meant for sockets? So it is basically how different commands will talk to each other. So let us say I want to have a program which will keep listening to incoming requests and process them. Okay, so I will actually open a socket with a particular number, and then I'll just wait for any information to come through that socket. Okay, and whatever comes through that, I will process it and do some action. Okay, so like that, you can have some programs which can just listen to incoming information and do some actions by opening sockets. Most of the systems, utilities are implemented using sockets for communication. As a regular user, you may not need them very often, but if you are into network services, if you are into running services on systems that are looking for requests from users and provide them with some data, etc., running 24/7 in the system. So understanding the socket concept is a very good idea. Yeah. Okay, next.
Sir, I have a question regarding hard links. When we type ls command, it shows the number of hard links present there.
Yes. Yeah.
How can we know the location of all those hard links if we want
Yeah.
to list them out?
Yeah, I will show you. I will show you. So they are all are sort of expected locations, except for hard links that are created by users somewhere else. So usually hard links are available within the same directory. So the directory will have one link. In the directory there is a dot that also is the same link. And then if you go to one directory below that level, then there's a parent directory of that directory, which is the same as current directory. So that's also one more hard link. So you can sort of expect what are all the hard links for any directory. For a file, it's a little hard because you could create a hard link for any file in any other location in the same physical hard disk. So that's a bit little tricky. I will just show you where it is possible, where it is not possible. Okay, Pradeep,
Okay, sir.
so
Thank you.
yeah, thank you. Pritodeep has made a comment. Yes, that's true. Socket files and sockets are referring to the same technology. Okay, sockets basically is a way by which you are trying to communicate. Socket files are basically files that act like a socket. Basically, they keep a socket open and then keep listening. Okay, so you can actually create socket files as a user. In fact, I have done it long back as a student to do some spying on some system that I was running because I wanted to keep an eye on who is coming and accessing the files that I have, etc. And so, yeah, I mean, if you know about it, you can do things.
Yes, sir. Got it, sir. Thank you.
Yeah. So permission string, I hope by now you are familiar with the binary system. So the 3 characters 755. So what you should do is take any of the numbers. Let us say take 5. So split it into the powers of 2. So 5 can be thought as 4 plus 1. So 4 is 2 raised power of 2. So 2 raised power of 2 plus 0 into 2 raised power of 1 plus 1 into 2 raised power of 0. Okay, so like that, if you imagine, then the RWX positions can be switched on and off. So 5 will be 4 plus 0 plus 1, and therefore it will be like R minus X. 7 will be 4 plus 2 plus 1, so it will be RWX. So if you had just 4, it means just R. Okay, if you had just 1, it will be X. If you had just only 2, it means only W. Okay, now W alone doesn't make sense because how can you write a file when you can't read it? It's a bit tricky. It doesn't make sense. So that's why you don't normally see W alone. Okay, you see RW, and then X. Pras is asking, are we going to study about spying? In other words, creating sockets? I'm sorry, I don't teach that in this course. If you are very interested, maybe we can talk separately. I can give you some tips on how to go about that. Not supposed to do it too much because you know that there's an IT Act in place. So unauthorized access to information is also not accepted in the legal system. Normally, we are allowed to spy on a system where we are the owners and we are doing the spying to ensure the safety of the system, etc. So there is a certain gray levels that I don't want to get in. That's why public lectures like YouTube videos and all, I don't want to talk about them. But I am experienced with some of it. So if you are interested, I can give you pointers. This is not a networks course, so I don't want to talk about that. So here are some commands like chmod, touch, cp, etc., which are used for your daily life requirements. Like chmod is to change the permissions.
Sir, in the
Touch to
previous slide, I am not able to understand the numbers associated with the code.
yeah. So
RWX, I understand 7, but then
okay.
others I am not able to understand.
Yeah. So 6. Okay, think of 6 as I will write it in the chat window. So I would say the R is corresponding to 2 raised power of 2. Okay, then W is corresponding to 2 raised power of 1, and then X is corresponding to 2 raised power of 0, which is basically 1. Okay, now what you do is that whenever you have a number, try to see what combinations of 2 raised power of 2, 2 raised power of 1, and 2 raised power of 0 can you think of, which is basically 4, 2, and 1. Okay, so what combinations of 4 to 1 can you use to get that number? So 4 comma 2 comma 1. So let us say take 5. So 5 can be thought of as 4 plus 1. So 4 is for R, 1 is for X. So R and X will be on. Okay, that's how it is.
Fine, got it. Thank you.
Okay, this is a straight mapping of RWX to 4 to 1. Yeah, and think of them as toggles, yes or no, on and off. Yeah, don't by heart. Don't have to by heart. Yeah. Okay, so these are the commands to for your daily life to create a directory, to move stuff here and there. So MV is to move the files or to rename files, and CP is to copy a file. Make dir is to create a directory. RM is to create a file. RM minus F can be used to remove a directory also. RM minus RF can be used to remove directory along with its subdirectories and files, etc. It's a bit dangerous, so don't do it unless you know what you're doing. So RM minus RF, okay, is a dangerous command. Okay, RM minus RF is a dangerous command, because if you do it on your home directory, then you will lose everything in your home directory. So watch out. Okay, so because in Linux, the philosophy is always that people know what they do. Okay, they expect people to read, understand, and do what they are supposed to do. So by default, it doesn't prompt you. Okay, so it's a very good idea to make the commands to prompt you. So what you can do is run these commands: alias rm is equal to rm minus I. Okay, alias cp is equal to cp minus I. Alias mv is equal to mv minus I. Okay, now if you type these three commands, it will actually tell the shell to inquire before it does action. Rm minus I means inquire whether to remove or not. Cp minus I means inquire whether to copy or not. Now it's a bit silly in Linux if you try to do that, because I mean, if you're not sure about copying or not, then why did you write the command? That's the idea basically. So that interaction mode is actually also a pain, because it doesn't allow you to do automation. Okay, because it is expecting you to give an answer, and who is there to give an answer for automatic scripts? So that's why most of the commands are by default not interactive, but you can make them interactive or to inquire with you whether it should do it or not with a minus I option. As a learner, as a newbie, have it, and once you are comfortable with commands and you know what you're doing, remove it so that the work is done silently. In Linux, silence means job is done. Okay, silence means job is done. Anything error, it will tell you. Okay, if there is nothing said, it means the job is done. Okay, it's a very mafia type of output. So it does the action, that means it's done. So no unnecessary messages on the screen. Okay, yeah, next.
So, sir, this is the
Yeah.
last one.
Okay,
And
now then let me now go to the
yes,
sharing, and I will try to do that thing.
yes,
Huh?
yes. So, sir, if you can, along with the Hardlink Softlink, if you can discuss about local and absolute paths also. It is
ठीक
actually
है.
useful in both MV and CP and Hardlinks as well.
Okay, yeah, I will do that
That's
right away.
yeah. These guys were facing issues. I saw that.
Okay, okay.
Okay, sir. I'm stop sharing this.
So are you able to see my screen?
Yes, sir.
Okay, fine, good. So so here I am in my screen, which you are also familiar, because it is the same machine, same computer where I was recording the videos.
Yes.
Okay. So the first thing is about the inode number. So what we'll do, ls minus I, if I type, so for every entry, if you compare that with the ls command, so you can see that for every directory or every file, there is a number that is printed in front. So that is basically the inode number. You can think of it as an identity for the file system. Okay, in the file system, it has to say, file number 1, file number 2, file number 3. So something like that, a sequential number is being kept track, and that is what is the number. Okay, now what I will do is that I will create a directory. Okay, so for today I would say 03 June. Okay, and I will go there, and then there I will try to illustrate. Okay, so file 1. Okay, so I have created a file 1, and the contents are, this is file 1, that's all. And ls minus I, if I type, then I have got an inode number, which is 18752032. That's the number of the file, okay, in the file system. Now, if I want to keep a hard link for this file, what it implies is that I am trying to keep basically one more entry for the same file. One more entry means name is different, but it's the same file. It's like saying Kamal Kishore Chaurasia is called at home as Bablu. Okay, so when you go home and say Bablu, the same person will respond as Kamal. Okay, the same person, two names. So that's the idea. Okay, so the way to create is with the command ln. Okay, so man ln, if you look, making link between the files. So ln is for the command. Okay, so ln, and then file2 is the link that I want to create, and of what is file1. Okay, sorry, the sequence. Now you see that file2 has been created as a link, and it has the same number of bytes. It has 14 bytes. Okay, now if you see, I have not edited the file2 yet. I have not done anything yet. So I will go and see what is in the file2. You see that it says this is file1. So you know that the file2 and file1 are same because the content is same. Now what I will do is that I'll edit the file2 and see what will happen. Okay, I will edit the file2. Okay, I am editing file2. Cat file2. Okay, I have edited the file2. Now what happens to the file1? It has the same content. So which means that file1 and file2 are actually the same file. Now this can be confirmed if you put inode numbers. You see that both of them have the same number. Okay, that means that they are basically the same file. So this is the idea of a hard link. Hard link means the same file, different names, same file. Okay, now what I am trying to do now is I want to show you that there is some problem in case if you try to do it for a file which is not on the same disk. So I am here having a USB stick. Okay, I'm going to stick it into the computer. Okay, and then okay, and it has created the directory here. This is my USB stick, and I can go and see what is there in that. It is sitting in media by gfunny by something. Okay, it's the name of the disk. So it is, this is my disk. Okay, this disk is actually a bootable disk, so it has some kind of a files and all that. Now what I can try to do is, if I try to create a hard link for a file in my other directory, if you look at the df command, if you see my home directory is sitting in slash, this is a one device which is SDA5. My disk is this disk. They are separate disks. So we can try to create a link between these two, and then we will see there's a problem. Okay, I can also go to the other one. So I can go to any of these disks. Both are, two partitions are there. Okay, now what I will do is like this. Here I try to create a link for if you look at the format I have done. Okay, so the what is the original file that I'm trying to link, and here the original file I will put it like this, home gfunny by 03 something. This is a file, right? Okay, this is a file, and I want to create the link here in this location. You see, it doesn't work. It says failed to create hard link, invalid cross device link. So this is something that I want you to learn and remember. Hard link means it's the same file with two different names, which means that it has to be in the same disk, because the same file means it is in the same location, which means in the same disk. So you cannot have the same file in two different disks. So that's why hard link cannot actually work across disks, physical disks. Now I am seeing that I am trying to link home by gfunny by folder, that is actually one disk, which is a different, here if you see here, it is one device. And then I am trying to link it with the local folder, which is actually a different disk. So I'm trying to create a hard link between two different devices. Nahi chalega. Okay, that is not possible. But you can create a soft link across devices. In fact, that is the purpose of creating soft links. Soft link idea is as follows. It is a pointer. Okay, it's a pointer to the different file. So let us create that soft link now. Soft link can be done with the -s option. -s means soft link. It has come out without any problem. Okay, now you can see that soft link is available. File2 is pointing to that file. Now you know that I have created a soft link just now in this hard disk. I have not done anything to that file. I will see what is there in that file, and you see that the same contents are there which are in the other location, which means the soft link and hard link, when it comes to the contents of the file, they behave the same way. But there's one difference. If you remove soft link, the original file doesn't get disturbed. But if you remove all the hard links, the file will be gone, because hard links are the files itself. Okay, and soft links will exist even though the pointee, that is, I'm pointing to something. What I'm pointing to is removed. The link will still be there, but it will be blinking because it knows that the target is missing. Okay, so I will just show you that now. So I go to that folder. Okay, I will remove file1. Okay, I removed the file1. Okay, what is the content? Content is safe because I have kept one more copy called file2, not copy, one more name for that file called file2. So that is there. Now let me go to this fellow. And here, if I want to look at the link, and you see it has become red because file2 is pointing to file1 in my home directory, which I have removed. So if I try to see what is the content of file2, it's not there. But is it true that the file is missing? No, there is another name of the file which is called file2. Okay, that is there, but the file1 is missing. Okay, so this is the difference between symbolic link and hard link. Hard link means different names for the same file. Symbolic means a link, okay, as a pointer. So when you are doing a pointer, that pointee has to be there. Only then you have the access to the information. Otherwise, you don't have access to the information. But advantage is that soft link can be across devices, across physical devices, which is very powerful concept. So that's why in Linux systems, you can expand the capacity of the storage indefinitely, keep on adding hard disks as you keep on using the system without having to, replace the hard disk and all that thing every time you exceed the capacity. The power is because of soft links. You can create soft links and keep expanding the hard disk capacity by just making folders that are mounted elsewhere. So it's a very powerful concept, which incidentally doesn't exist in traditional Windows operating system file systems. So there is no concept of these links. It has come little later, but not implemented as elegantly and powerfully as in Linux. Okay, so that is something that I wanted to share. Now there is another thing I want to, of course, now remove the USB disk. So
So
I
may
will
I
just,
ask a
what I will do.
question?
Sure, yeah.
So whenever we have used this ls-l command, on the immediately after the command, we see something called total 4, total 8. The last command that you use showed total 1957.
Uh-huh.
So what is the meaning of that total and the number?
So this is actually the number of entries it is actually showing you. So these are the number of hard links. If you see here, you have to add all these fellows that are in the hard links in the first second column here. 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 2 plus 2 plus 32 plus 2, like that. So these are the hard links. So the total number of hard links available are 68. Okay. Now why is this folder showing you 32 hard links? Let me go and look at it. So it has a lot of folders. Every folder has a hard link, which is basically double dot. Every double dot is a hard link upwards. So therefore, it will add the number of hard links. Okay, I will illustrate that to you right away. Okay, now total 4. Okay, now what I will do is I'll create a directory 8. Okay, now I'll go to the directory inside, make xab. You see the number of hard links has increased yet from 2 to 3. And then I go to XAA, XAB. You see, I have got 4 folders. Each of them will actually have their parent directories kept, and therefore, if you see, there are like that many hard links up. Okay. And I can do the same thing here. Okay, I have got so many hard links created. I come here, and that many parent directories are created, and that's why the hard links count has increased. Again, I will create here. Okay, so many hard links. You can see that the number has increased. I come up here. Okay, now you see that this fellow, earlier it was only 2, and now it has become 8. So these hard links are dependent upon how many subdirectories are there one level below whose parents are there with me. So every child directory, the double dot is a parent directory is a hard link, so therefore that will be added to the number of hard links. So that is the count that is being used to sort of display, because it is inquiring the file system and asking how many entries are there, and then that entries are being shown basically. So strictly speaking, it is like the number of entries.
Excuse me, sir.
Yeah, yeah, Pritadeep, yeah.
Yeah, sir, I have a question regarding the hard links. When you deleted file 1, we could still access the contents by going to file 2.
Yes.
So can we say that a hard link is basically a copy, and by extension it takes double the space in total?
I wouldn't want to say the word copy. That's why I'm giving the name of, let us say, who was the student? Kamal and Bablu. See, Kamal and Bablu are not copies. No, they are 2 names for the same file,
Okay,
right?
yeah.
It's the same file. It's not a copy. Copy means I have got two things of them. But actually, there's only one thing. There's only one file. There are 2 entries. Okay, one entry you remove doesn't mean the file has gone, because there's another entry which is accessible to it. So file 1 and file 2 are entries to the same file, and inode number is the authentic way of saying which file. So because the inode number is same, it means it's the same file. I mean, that is
So
a better way
do
of
we?
remembering.
Yes, I got it, sir. So does creating hard links take up more space? I mean, are we
No,
wasting
no, no,
space?
no. In fact, it's the other way. Hard links are even created when you're taking backups to ensure that you don't waste and make copies unnecessarily. So let us say I have some 10 files, and I want to keep them in the yesterday's directory and day before yesterday's directory. So instead of copying them, I can create hard links in those directories. Then what happens is that if I delete in any directory, the original file will still be there because it is there in at least one of those folders. So backup will be kept. Now, when does the file get deleted? When all the hard links have been exhausted. Okay, that's the reason why you can say that a file is deleted. The file is deleted when all the hard links have been removed.
Okay, sir, got it. So is there any command like maybe superior to RM, like we'll delete everything including all hard links? Is there some command like that?
Yes. Let me just note it down so that I can just look it up and put in the notes. There is a way by which you can actually go and wipe it off. Okay, so I would say,
Got it. Thank you.
yeah. Okay, and there's also a command to ensure that when you remove a file, the bits which are written on the hard disk are also erased and made to 0, so that somebody who has stolen your hard disk cannot go and retrieve the files and then discover what you have written long back, etc. So this is used by some security labs, or DRDO labs, etc., who work on sensitive things. So when they delete some files from their hard disk and they are going to dispose the hard disk, what they do is that they will actually write zeros in every location in the hard disk. It will take several hours, and then they will dispose, so that even if somebody finds a hard disk, there's nothing that they can read from the hard disk. Right now, if you throw your hard disk, you are actually throwing all the data, except that you are not giving the information which file is where. That's all. Other than that, files are all still there. Not many of them are not erased, and therefore one can retrieve the files. So there is a way to erase it really hard when you delete a file also. Okay, I have noted it down, so I will put those things in the notes also. Okay,
Just
so securely removing it basically. Yeah.
So just one thing, sir, more towards Predodip's question on CPA and copy and hard link. So I would suggest you guys to create yourself a copy of a file and a hard link, and try to change the contents of the file and see which file changes the contents of others file also. So what I meant to see is that if you change the content of file, the content of copied file won't change, but the contents of hard link file, if you access it through other hard link, it will change. This is because the hard links points to the same file, and copy is a different file.
So we can now do here in the screen
Yes.
you are seeing file2. So what I will do is that I will link file2 to file1. So now you have got file1 and file2. They are basically the same entity. Then I will actually have a symbolic link file1 to file3. So you can see that file3 is a symbolic link to file1. Okay, and then I will copy file1 to file4. Now you see that file4, file1, file2, all of them have same size. And if you look at the inode numbers, file1 and file2 have the same inode number, which means they are the same file. File3 has a different inode number, which means that actually it's a pointer. It is only occupying only 5 bytes, so it's only a pointer. File4 is actually same size as file1, but the inode number is different, which means that it is not the same content. So now what I will do, I will change the file1. Okay, file1. Okay, so I changed it now. Okay, cat file1, cat file2, cat file3, cat file4. You can now see that file1, file2, file3, all of them show the same content, but file4 doesn't show because file4 is a copy of file1, and when file1 changed, file4 did not change because it's a different file. It's a copy. Okay, it's a separate file, but file3 is a symbolic link to file1. Okay, therefore it will actually reflect the contents of file1, which is same as file2. So I will go and change it to file2. Okay. I am editing this as file2, cat file2, cat file1, cat file3. So you can see all of them will change, which means that file2 is edited, file1 also is getting changed, file3 also getting changed. So hard links and soft links are pointing to the same, so therefore they will both reflect. Where is the difference? The difference is if I remove, what will happen? So I will remove file1.
Sir, just a minute. Before
Okay, I
this,
will
can
cancel
you,
the
sorry to request this, can you show what will happen if you edit file 3?
Okay, sure. File 3. Cat file 1, cat file 2, cat file 3.
Why,
I can edit
I
it.
mean, why file, changing file 3 also shows it in file 1 and file 2?
Yes, because file 3 is a pointer. It's only pointer. So when I'm accessing file 3, what the system does is it will actually give you file 1. Now file 1 and file 2 are identical, so there's no problem. Okay, now where the difference comes is as follows. I remove file 1. You see what happens. You see what happens. Okay, file 1 is removed. Now what happened to file 3? File 3 is pointing to file 1, which is not there. So what happens if I try to access file 3? It's not there. Does it mean the file has gone? No, the pointer is invalid, but there is another name for the same file, which is file 2. Content is still there. Think about this. What you are seeing on the screen, just think about it. File 1, file 2 are names of the same file. File 3 is a pointer to file 1. File 1 is removed. Content is not lost because file 2 is another name for the same file. Content is not lost, but file 3 is pointing to file 1 because file 1 is removed. File 3 pointer is a dangling pointer. It doesn't know where is it supposed to head, and therefore it says no such file. So that's why symbolic link is different from hard link. Hard link means same file, different name. Symbolic link means a link. So when you're having a link, it doesn't care whether the file is there or not. If it is there, it will access. If it is not there, it will be dangling. That's all. Okay. And meanwhile, we have done so much of editing. What happened to file 4? It is still the old content because it's a separate file. Okay, you can see the inode number. It's a separate inode number. It's a separate file.
Sir, you were saying that file 2 is a hard link of file 1 and both have the same inode number.
Yes.
So when you deleted file 1, how is that file 2 is still showing the contents when it's denoting to the same file which has been removed recently?
So in the file system, the way it is writing is as follows. It will be noting it out in this way. Example, I will. Okay. Example, I will give you. In the file system, it will be remembering like this. Okay. File 1 is at inode number this. So it will be remembering something like this. Okay, this is how it will be remembering inside. Okay, all the entries are pointing to inode numbers. So when you say remove file 1, what it does is it is removing file 1. File 2 entry is still pointing to the inode number. When does file 2 go? When I remove this also. So if you have, let us say, 4 hard links, the file is there as long as there is at least one of them. Okay, if I remove all the 4, then the file is gone. Until that time, the file is still intact. Okay, I will give you that example. I will give you that example.
All fours are 4 different names for the same file which is existing in one disk only. One disk only. So if that main file is going, how is that the other 3 which refer to the same destination show the content?
Because inode number is the same. So so please don't associate the file with the file names. Associate the file with the inode number. The inode number is still there, and therefore the file is there. The inode number has a name called file 1. The same inode number has a name called file 2. The same inode number has a name called something else. So when you remove all the names, then the inode number is gone, and that means that the file is deleted. Until all the names are removed, the file is there. And these names need not be in the same location. They can be anywhere in the same physical hard disk, which I will illustrate right now to you. So file 1, I will remove file 3 because it's a dangling pointer. I don't want it. So file 1, file 2 are here. Remove file 4 also. Okay.
Sir,
now what I will do, I'll come out.
Confused with file 4 also. File 4 is a copy.
It's a copy. So it is totally different file now. Okay. So I'm just now what I'm doing is that outside the home directory, I'm just create a link. Okay. So link to 03 something by file 2, and I will link it as file 1, which is actually okay. Okay, I would say at home. Then I will go somewhere else to documents folder, and then I will say link 0. Then I will come to downloads. Now let me go there and see. Now you see this is a file 2. Okay, it's in one location. Where all it is stored, I do not know. Okay, what I will do, I will edit it here. Okay, I will edit it here. File 2. Okay, so cat file 2. So I am editing it where as of this location I'm editing it. Now I will go up and look at this file. It has the same location, same stuff. I will go to documents. Okay, and file for contents, same location, same contents. I'll go to documents and more file 3. So everywhere it is located, it is having the same contents. Now I will edit it here. From documents, I'm editing it. Okay, file 3. Editing the file as file 3 in documents. Okay, I'm editing it in documents. I go home. It has changed there also. I go to the original location from where I started creating. You understand? It's the same file, same inode number. It has 4 entries. What are the 4 entries? One is in the home directory, one is in the downloads, one is in the documents, and one is in the 3rd June 2022 folder. 4 different folders, 4 different names, same file. Now, where is it useful? Usefulness is because, okay, I want to clean up this file. I will remove file 2. Okay, I have kept my folder clean, but I have the stuff still available. I remove here also. I go to documents. File is still there. So you see the advantage.
Okay,
because
sir.
it has multiple entries. You can delete some of the entries. Doesn't matter. The file is still there. When does it disappear? When all the entries are gone. Okay,
So
I have created 4 entries.
Hardlink and Softlink from editing perspective behave the same way.
Yes, from editing perspective, behave the same way. But when you are removing, the hard link will actually remove the file only when all the hard links are removed. Whereas the soft link will be invalid the moment you remove the target.
And the only benefit to create a soft link is that it occupies lesser size.
Not only lesser size, it can point across the physical device.
Physical device, yes.
Yes, that is the most, in fact, that is the first purpose.
You create a soft link and you edit the pointer, you can still get the contents across to the file to which it is pointing.
Yes, because yeah, as long as it's a live link, you have access to the original file. Yes. Okay, so I hope. I mean, so you have to contemplate a little bit on this, see what I have done, try it out yourself also, and you know, it should sink in your mind that file name is not the file, inode number is a file, file name is only an entry. Okay, that's what I want you to remember.
Sir, it's like, sir.
Yeah. So can I share the screen? Just a second.
Yeah, I will do that. I'm also done with my demo, so I'll just stop it. Yeah.
Yeah, just a second. I will share the screen. You will, so you can use this slide. I've just now prepared for the example you gave.
Okay, good. Yeah. So you can see that file 1, file 2, file 3, they're all basically pointing to the same location, but the file 3 is pointing via file 1, which means that if the file 1 is removed, file 3 will be dangling. Okay, but the first partition of the disk is still available because you have not removed that content. So file 2 is still available with that particular content. File 4 is a copy. So file 4 is sitting separately. It has a different inode number. So Ankur, the boxes in the disk can be labeled by the inode number.
Yes, sir. I can write inode 1, inode 2.
Yeah, basically it is like 1, 2, 3, inode number 1, inode number 2, like that. So
yes,
that is the imagination that I would like students to have. That is, what is on the disk is actually inode numbers, which are then entered in the file system with some labels saying that a file 1 hai, a file 2 hai. But inode number is the actual file.
Yes, sir. Yeah, I can clear it later. Now it's
Yeah. So this is the idea. This is the idea.
this is the idea.
So what is the file is actually the inode only, and the entries are multiple. You can have multiple entries by using hard links. You can also have them as pointers using soft links. And when does a file disappear? When all the labels are gone. That's all. So when all the labels are gone, what happens is that the file system knows that this inode number is not available in the listing of any entries. That means it is available, that space is available. So it will go and use it for some other file. That's how it actually works.
Okay, sir.
Okay, good.
So there was some question. Yeah, go ahead.
Yeah,
Please.
let me see chat window. Okay. So any question? Yeah. Right now there is no question that is sort of open.
Somebody was
So
speaking something. I interrupted actually.
yeah, no problem. Let them ask by
Yes.
unmuting. No problem. Yeah. Feel free to unmute and ask.
Sir, I was just saying hard links are the names for the same physical existing entity.
Exactly.
And if deleting those hard link means I don't want to call that a physical existing entity with that name particularly,
Correct.
but
Yes.
I can call it by other name. But
Yes.
soft link means I am referring to some file, some hard link. That means some file with that name. But if that doesn't exist, I will not be able to refer to that entity anymore.
Yes. Because it's a specifically to that entry, and therefore if that entry is missing, then I don't know what to point to basically. So that way soft link is having plus and minus. The positive thing is that it can point to locations across physical disks. Negative thing is that even though there are other hard links available, if the hard link that I am pointing to is missing, then I am not able to access the content. So that's a plus and
Yeah.
minus. Yeah.
Yes, sir.
Good.
So, so should I share the next slides, combining commands and files? That is the next important topic.
Sure. Okay. So that is only a revision, so we can just rush through.
Yes, sir. Can we see the slides?
Yeah, we can see it.
Yes.
Okay, so these are all the various ways of combining commands without actually passing on information from one to another. These are all basically executed separately, but they are done in a particular manner. The very first way of combining by putting semicolons means that run the command 1, whether it is successful or not doesn't matter, run the command 2, whether it is successful or not doesn't matter, run the command 3. So they'll be running one after other. That's all. So the success or failure of the first command doesn't affect whether you run the second command or not. Okay, that is one way of running the commands on the same command line. Now, when you have the double ampersand, it means that I want the answer to this particular combination to be true, which means that if I run command 1 and if it is successful, only then I will run the command 2. Okay, only when the command 1 is executed successfully, then I will run the command 2. Otherwise, I will not run command 2. When is it useful? For example, I want to change to a directory and then do some backup. Now, let us say due to whatever reason, I am not able to change the directory. Then there's no point in doing the backup. So that's how basically situations where the first command failure doesn't make sense for the second command, then you use a double ampersand. Now, double pipe is a different scenario. Double pipe is actually command 1 or command 2. Okay, that means command 1, if it is failure, only then command 2 will be executed. Okay, that means that it's like saying that do this or that. Okay, the first thing succeeds, job is over. First thing doesn't succeed, go to the second thing and do it. Okay, so you can see that these are the three different ways of combining commands, and the use cases are available. I have already discussed in the video. The use case of the first way of combining by semicolons is run all the commands without any botheration which one is successful. The use case for the second is run command 2 only if the first command is successful. The use case for the third option pipe is run the command 2 only if the first command fails. Okay, so that way you can actually imagine and then try to combine. Okay, next. Yeah, Ankur, we can go to the next.
Change the slide. Is
Yeah,
it not
okay.
visible?
Now it has come. Now it has come. Okay. Now
Yeah.
maybe we stop with this because if this is very clear, then rest of the combinations also will be quite clear. So it's very important. The entire combination of commands on the command line should be imagined like a Lego. Okay, so you know that those Lego boxes, Lego toys can be combined with each other to make a bigger toy, right? So every command is like a Lego. It has basically three connections. One connection is a input, which is called a standard in, and also called as a file pointer 0. And then two outputs. One output is called standard out, which is for the regular output, which has to be shown. Then second one is called standard error, which is whenever there's an error that is encountered, the file pointers are 1 and 2 respectively. And by default, standard in file pointer 0 is from the keyboard. That is what is entered into the command is extracted from the keyboard, and what is displayed out is displayed onto the screen. Okay, so by default this is action. However, you can combine the commands so that the standard in of second command is coming from the standard out of the first command. Okay, so like that one can have a daisy chain of combination of commands so that you can pass on the information without writing it intermediately, so that multiple commands can execute in tandem. Okay, now everything will be communicated in the memory, so it's very fast, and that is actually the heart of Linux command line. Okay, the heart of Linux command line is ability to combine commands on the command line so that the standard input and standard output are linked between commands so that information is passed across commands without any intermediate storage. Okay, that is a very powerful feature. Try to have that as your imagination of how commands work, and then everything else makes quite a lot of sense. Okay, yeah. Okay,
Sir,
next, let us.
I've changed the slide. Is it not
uh,
working?
Now it is working. Yeah.
Actually, I will
Now,
close this if there is an issue. Yeah. Okay, sir.
okay, now it's fine. So this is a simple redirection command greater than file1. If you run that, what happens is that the standard output of the command is pointing to the file1. So whatever is output is then written to the file1. But if there's any error, it will write to the screen. Okay, that is the meaning. So when you run a command, and in the process of running the command, lot of output is coming, and you want to keep the output in a file so that you can read it slowly, you can do this command. But in the process of running those commands, if any error is there, it will appear on the screen. Okay, so this is a very standard way of using. So the cartoon should illustrate to you how the information is flowing. Okay, so it's not as if every output is put into the file one. Only the standard output is put into file one. Standard error is still into the screen. Now we can also pass standard error to a file. I have shown it in another slide. Okay, so let us go to the next. Okay, now command double greater than means that don't override the file one, append it to the file name. So that's why my arrow is actually at the bottom of the file, showing that I'm appending to the file one, so that if the contents of file one are there, it will not be lost. It will be just appended. It will not overwrite the content. Okay, yeah. Next. So this is the other direction I was mentioning just a while back. So greater than file one means output will be sent to the file one, but two greater than file one means send the contents of the standard error to the file one, which means that send only the error to the file one. Output should be to the screen. Okay, so this is again a place where the errors are not shown to the screen. It's stored separately in a logbook or something. Only the neat output are shown on the screen. So this is also a very useful, combination of file and command where the errors are not to be shown onto the screen. Okay. So you see the difference greater than and two greater than. Greater than means standard output is going to the file. Two greater than means standard error is going to the file. And you can combine them both also. So you can send output to file one and standard output to file one, standard error to file two. You can do that also. Okay, next. Okay, that's what we have done here. So the output is sent to file one, error is sent to file two. Okay, you can do both. Okay, this way nothing will be on the screen. Okay, just go back. What is output when you run this command? onto the screen. What is output on the screen? Nothing. Okay, there's nothing on the screen, which is a very beautiful thing, because when you are running some automatic commands, or when you are running in the background and on some automatic job, you don't want anything to be shown on the screen because it is running in the background by the system. So this is how people use for automatic commands, where the output and error are written to the files but not to the screen. There is nothing on the screen. Okay, so that is one powerful feature. Yeah. Okay, yeah, next. Okay, input is a different usage.
So, sir,
So
on there is a question on the chat. Is there a command to append the errors?
So I have not come across that. I will have to see. Okay, we can try it and check it out. But I have not seen that usage at many places. I have not seen the usage. Maybe because the errors are not very common, and then all that you want is to just keep it in a file. That's about it.
Kind of logs, sir.
Sort of. Sorry, logbook.
Whatever logs,
we can try that
whatever
out.
logs are generating.
Yeah, you can, in fact, right away I'm going to do that as you hold on. So okay, I'm just trying to get some error somewhere, and then okay, I don't. Yeah, so it works. So you can use it. It works. So you can combine, 2 greater than twice, so that you are appending the standard error to a log file. Yes, that works.
But without the number 2.
No, with number 2, of course, because you want to append the standard error only, no?
Someone said that they are getting error. They tried
no error.
They tried to Srinath, right? This is what you tried.
No, I didn't try actually.
Aras said that he tried error something. Yeah.
No, there should be no.
I was
there
asking
should be
whether
no.
This will work because
It
previous
work.
slide,
It work.
yeah.
Just now,
just
now
query
I
only.
tried.
I just wanted to ask.
Yeah. Just now I tried. It works. So error appending is also possible.
Okay.
Normally people only do standard output appending, so that's why I discussed that. But error appending is possible and it works.
Thank you, sir. Thanks, Abul.
Yeah.
So next slide.
Yeah. Okay. So now this is again the same thing, but a redirection of the pointers. What we are trying to say is, when you say greater than file 1, we are saying the standard output should go to the file 1. Okay, that's done. Now 2 greater than ampersand 1, ampersand is saying that the error has to be redirected to the file pointer 1. And what is file pointer 1? Standard out. Now what is standard out? Going to file 1. So it then goes to the file 1. So 2 greater than ampersand 1 just says that send the error to standard out. Okay. Now we happen to combine it with greater than file 1, which means that it is going to file 1 eventually. So 2 greater than ampersand 1, there should be no space between them. So 2 greater than is saying that redirect standard error. Ampersand 1 says to the file pointer 1, namely standard output. So together, if you read it, it will be saying that redirect standard error to the file pointer 1. That's what it says in the second part. The first part says greater than file 1, which means that send the standard output to file 1. So the outcome is finally, when the command is run, the output as well as the error are sent to the file 1. Okay, that's what is the outcome. Okay, here there's a pipe. Now pipe actually means default. Pipe means standard out to standard in connection. Okay, so remember pipe is always that. Okay, pipe means standard out to standard in. Okay. Now rest of the things behave as normal because they will all be shown to the screen. Yeah. So if the ampersand comes after the greater than symbol, then it means that you have got the pointer redirection. But if the ampersand comes before, it may actually put the job in the background because the ampersand coming after the command means the command should be run in the background, and the greater than symbol will be shown as if after running it in the command background, if there is any output, what should it do? So the interpretation is quite different. So the ampersand is after the greater than symbol. If it is before, it will be interpreted as if you want to run the command in the background mode, because command ampersand means run the command in the background mode. Okay, so it's very different meaning. Yeah. Snehil, input you cannot write, you can only read from it. So that doesn't actually work. Okay, it doesn't actually make sense in the sense 0 is for input, so you don't write to input. You can't write to a keyboard, no. You can only write to a screen or a file. So therefore 0 should not be used as a redirection destination. Okay. Yeah. Okay, dev null is a very special file. Okay, it's a sink, it's a black hole. So you want to send all the errors to some black hole. What you do is that you say 2 greater than dev null, then the errors are disappearing basically. So don't copy anything in dev null because it's going to basically a black hole. It's a sink. Okay. So infinite space basically. Whatever you keep in that, the file is still showing 0 bytes. So it's like an infinite sink. Okay. It is, the purpose is basically to provide a way by which you can dispose some stuff by redirection, and that's what it is doing. So what does it the device do is, whatever the input is coming, it will just take the bits and just simply throw them out. That's all.
Sir, will it store on hard disk or it will just?
It is actually not sitting on the hard disk. It is actually a memory feature. So really nothing is stored when you copy something to dev null. Nothing is stored anywhere. It is just disappearing into the thin air. In the memory itself, it is gone.
Okay, sir.
Okay, it's a feature of the file system. It's a feature where you are trying to tell saying that I don't want this. So it's like I'm saying that I want to just throw this basically. Now what does it do? It's in the memory. It just simply ignores it. It's like throwing something out of the window from an aircraft. Really doesn't matter where it goes basically, right? It just goes.
Okay, sir. Sir, can we do diagonal to files? Like I have a file, some text.txt, and then I pass it to /dev/null. So will it be gone for?
Yeah, I mean you know it's a file, so you can only copy it. So what happens is that it will be gone. Okay, the content will be gone.
The whole file will be gone, or the file will
1
be there?
second. Yeah. So when you say copy, you are actually copying the content. So it really doesn't matter because you're only making a copy, so it doesn't affect the file. Because always remember, cp command doesn't affect the original file. Okay, so when you say mv, okay, mv dev null, okay, then what happens is that the file will try to overwrite the dev null file, and the dev null belongs to the system, so it will not allow you. So basically that's not the way to remove the files. You can actually only redirect the output to sync, but not really the files. If the purpose of sending it to dev null is to remove, then rm command will be doing the job basically.
Okay, sir.
Okay, because cp command doesn't what do you call touch the original file, nothing will happen. mv command will not work because you're trying to overwrite a system file, so that doesn't work. So best is just use a rm command, the purpose is solved.
Okay, sir. Thank you.
Yeah. Okay, yeah. Next, yeah, here what I'm trying to do, the command is executed. Whatever is the output is sent to the file one. Whatever is an error is sent to dev null, which means it is ignored. Okay, so no error will be displayed on the screen. By the way, is there any output on the screen at all? Any of you tell me? For this command, is there any output on the screen?
No, sir.
None. Yes, none. There's nothing on the screen. Very neat. Okay, yeah. Next. Yeah, so T is again a very special feature. What it does is that it allows you to do some bifurcation of outputs, so that you can process the output at the same time send it to a file and all that. Okay, so yeah. Next, yeah. So you can do that. You can see that now. See, when you do a T, piping to T, piping is always with standard out to standard in, so that is done. And then the T command will always have its output split into two parts, file one and then the screen. It will do that both. So the T command is basically showing that I will keep the output on the file as well as on the screen. So it is due to the purpose of I want to have two copies of the output. That is the purpose basically. Okay, yeah. So these are sufficient for you to understand the purpose of combining commands. So I have shown you multiple ways of combining commands. So it's like saying that how can you connect various Legos? Now it's up to you to have fun by connecting various Legos and creating various shapes. So like that you can combine various commands and then achieve the task. So that's exactly the power of Linux command line. So never imagine that you have a single command line command which is doing your task. It may not be there. What is expected is that there is a combination of different commands. Together they will achieve the task that you want, which is very reasonable. Okay, so that's what actually you should target. So try to divide the task at hand into parts so that each part can be done by one command, and then you can assemble them using these features so that the task can be accomplished. So that is the way you should think. Then the Linux command is your slave. Okay, it will do a lot of things for you.
Yes, sir. So,
okay,
sir,
good.
Yeah. So we are already
Yeah, I think we are
not.
closing to the. Yeah, we are
Yeah.
closing the session. So maybe now we can just see for a few minutes we can ask if they have questions.
Yeah.
I think
Or
that
if
is
you want,
sufficient.
sir, there is one more important topic is left, that is pattern matching. If you want to say some important things about that in 5 minutes or so.
Well, I would only say one thing. I have given fairly comprehensive description of regular expressions in my lecture video. I want to tell you that there is more than about 250 different languages in the computer language repositories across the world where regular expressions are used. So I strongly recommend that you pay attention to the regular expressions. You will use them in grep. You will use them in ed, sed, awk. Then in VI editor, you will use them in Python. You will use them in JavaScript. I mean, name the language. You will use them in every possible way. Wherever string operations are involved, regular expressions are involved. So my suggestion is that try to start thinking regular expressions, as natively as possible, so that whenever is there any string, try to see whether I can match the string with any regular expression. That is the key of it. And I have given certain special characters and their interpretation, like the dollar is for the end of the string, hat is for the beginning of the string, and then square brackets is to give the options of different positions in the string. Plus is for one or more hits, star is for zero or more hits, and then flower brackets for the exact number of hits. Okay, so things like that. So please pay attention to these features. These are not many, so you can print them on a single A4 sheet, stick it in front of your desk, so that after some time you start getting familiarized with it, and then you will be a master at the regular expressions. There are some websites which actually allow you to practice regular expressions. So I am going to just quickly give you one such link. Let me just put one, regex practice. So there is one website, regex R, I think.
So one more thing, sir. Actually,
Yeah.
so last session that was on Wednesday, Krishnan covered
Uh-huh.
a lot of new examples. So
Uh-huh.
so he came up with those examples like without the questions from the students. So
Okay.
after watching the lectures, if you guys need any more practice examples, you can watch the Wednesday's live session.
Yeah. I think there is a supplementary information for them. Yeah.
Yes, yes, sir. So that's why we kept this in the last, because that was already covered on Wednesday.
Okay.
And just one more thing to add, that we will expect you guys to remember the syntax of the inside the graph, not the options, but at least the pattern matching syntax. Because if you practice that, it's nothing to remember. You will just know everything. And sir, there are some question. There's one question on the chat also.
Mhm. Okay, let me just see. Okay, so I think VA versus Emacs, one of them is sufficient. I think we are giving the option. You are free to pick one of them. And even in these, whenever there's a tricky or I would say involved aspect, we are providing help also. So it's not necessary that you have to by heart all the features. We are giving the help, but we would expect you to learn one of the two, because it's very important if you want to grow in the command line environment in the career. It's a lifetime investment, so it's worth doing that now. Okay, now or never. Okay, because I have learned one thing from my experience: those who know how to edit files within the shell go a long way in doing various scripting, etc. Those who rely on a graphical text window to do the scripting never actually go far, because they always have this difficulty with small editing that is to be done in command line. They always need a graphical interface to do even one small editing. So I have seen that a correlation. Those who are good in command line editing, either VI or Emacs, are the ones who actually become very good in command line usage later on in life. So I urge you to spend some time and learn. Given that I am also not expecting too much, so just only few questions, some couple of questions, that's all. So it doesn't penalize you from getting the best grade from this course if you don't know these editors. It's not like that. You can get the highest grade even without knowing VI or Emacs. But take it from my experience that if you know them, it's really going to help you.
So there,
Practicing all the Baskel examples from the lectures would be, I think, yeah, I think that much practice is good enough, I think. No?
so there's one more question from Pras. Are the regex options like caret hash functions common to all the languages?
Huh, huh.
What does it mean? Common to what
Okay.
languages?
Yeah, most of them. Usually what happens is that we are following the POSIX standard. Okay, so the options that I have given you are all POSIX standard, so they will be available in any POSIX compatible regex implementation. But having said that, there are implementations of regex which go beyond POSIX also. So there may be some features which I have not mentioned but are working in certain languages. Okay, but they are going beyond POSIX. Whatever is POSIX or international standard, those I have covered, and they will definitely be available in every POSIX compatible implementation. Okay, now is the implementation of regex POSIX? I do not know. It depends. Okay, you have to watch out. Okay, most of the time it will be followed by people, but it's something that you may have to ask.
So I didn't understand his question. I mean, what languages does he mean?
I mean, like in a Perl, Python, any language, there are some
Oh,
regular expression usages in every language. string comparisons and string editing, etc. So regular expression is used in many languages. So do all those languages support these features is a question. Answer is every language which is POSIX compatible would support all the options that I have described, because I have described POSIX compatible options basically.
Yes, anybody else? Any other questions? Sir is waiting for your questions, guys. So I think, sir, the session was highly interactive, and these guys have already asked their doubts during the session itself.
Okay.
Yeah, seems like so. Yeah. So and other technical doubts also related to quiz, what will be there, what will not be there, is also being discussed. So guys, I think if there are no questions, we can close the session.
Okay. Yeah. Okay, guys. So I hope it was useful for you. So look forward to meeting you again later sometime. Okay, and please do practice regularly. It is going to be a lifetime investment for you. It will help you a lot. So enjoy, and then see you around.
Yeah.
Okay.
So thank you, sir.
Thanks,
for the
everybody.
session.
Yes, Snehal, we can have a similar session for week 5. If sir is available, it will be very good. If not, then we will arrange that session for you guys. So
I
next
will
week,
try.
yeah.
I will try.
So, sir, what we
Okay.
are planning next week, that we'll have 2 code with us sessions. Like half of them will be code with us session. We will
I
have some
see.
examples that we will. So in Replit, we can see their code, what they're
Yeah.
saying, and they can ask, and we can correct the code if they face any
Okay.
difficulties.
Okay. So it is going to be in we can look at in Replit and help them. So
Yeah.
good. I think that's fine. So I will be in touch with you about the other session. So we will
Yes.
plan.
Sure.
I will try to be there.
We do that session every week.
Yeah. Okay.
Code with us session. Next week we'll have that 2 times.
2 times. So I may come later then.
Yeah. So we can discuss that.
Okay. Yeah. Let me know. For now, I will
Sure,
take
sir.
leave. Okay.
Yeah. Thanks a lot, sir.
Okay. Welcome.
Yeah.
See you
Thanks for
guys.
joining.
Thank you.
Thank you,
Thank you,
sir.
sir. Thank you so much.
Welcome. Bye.
Yeah. Bye, everybody. And all the best for your quiz. Good day.
Thank you, sir.
Bye, sir. Thank you.
Sure.